Hello everyone, welcome back to a continuation of high-grade covalent structures and molecular structures. So the element periodic table, in the fourth group elements, carbon and silicon, okay? So this is the second most common element on Earth, silicon. Occurs in many compounds, example sand, which is silicon dioxide. It's famous in silicon chips, okay? In electronics. Okay, let's just say silicon. Okay, it forms very rigid covalent networks, which are same structure as diamond. Okay. Next, B, okay? For that element. Boron, which is periodic table, the third group, okay? Silicon was the fourth. So boron, this is actually used every day by chemists, okay? For example, in the glassware Pyrex glassware, okay? Its strength, the strength of Pyrex and its resistance to heat plus and its resistance to high temperatures are because of due to boron oxide, okay, in the glass. So boron forms structure which is made of boron 12 groups, okay, which these bond to other atoms. Okay, so this means the element boron, so the element boron is almost as hard as diamond. Okay. Next, the noble gases, which are helium, neon, argon. What's argon? I use a periodic table, argon, Ar, and krypton Okay? Always look up things in periodic tables if you aren't sure. Helium, neon, krypton, argon, xenon. Always look up periodic table if you aren't sure. So, noble gases. If you pass electricity through, you get a colourful glow. Okay, this is used in advertising signs. Probably these LEDs now, this will be out of date probably. So it occurs to me in the right this that a lot of LEDs, light emitting diodes, now used for lighting. So this idea of noble gases being used to light may be old. I'm not up to date with the current technology in light in shop windows. Well, I know LEDs exist. It's a gas these, but they may use these neon lights. These are equal to neon lights. It's in the course. So lights, shop lights at night. Okay. Right. The bonding of elements. Bonding. Bonding of elements as you move to the right, the periodic table gets less and less complex, okay? So it becomes simpler and simpler. Complex, I think I said in the earlier video, means made in many parts. So it gets less and less complex as you go that way, okay? Rightward, right hand side. So it's least complex at the right hand side of periodic table. Okay? At the right hand side are the noble gases. All noble gases except helium have outer layer of 8 electrons. So they all have 8 electrons in the outer shell, which makes them therefore, this means therefore, very stable, unreactive. So they do not form covalent bonds or ionic bonds. Okay? The noble gases do not form covalent or ionic bonds because they're too stable. So these are called monatomic. These are called monatomic. Okay? And when they get cooled, they form liquid or solid. As you cool them more and more, they become solid due to Lorentz dispersion forces, okay? Pulling them together. So yeah, the London's dispersion forces make the noble gas, the noble atoms condense to form liquid and solid as you cool them. These attract the atoms together. Okay, then you got quick melting points and boiling. This pen's getting low. So phosphorus 4 and sulfur 8. These are discrete molecules, meaning they're a molecule which is finite size. The melting points and boiling points are low. They're low due to, it doesn't even work at all, due to weak London's dispersion forces. Okay, I'll put in the sheet. So phosphorus 4 and silicon 8 have low melting points and boiling points, okay? Due to our weak, this is too thick, this pen. Due to weak intermolecular, what's called intermolecular London's dispersion forces. Intermolecular, that's even worse. Go back to that one. Due to intermolecular London dispersion forces, okay? Intermolecular, so intermolecular equals between the molecules, okay? And intramolecular equals within the molecule, okay? So London's dispersion forces are positive and negative charges that occur, I said, around when you have a molecule. You get these are hydrogens. So you get excess of negative there and excess of positive there. Okay, so you get a movement of electrons are flicking to one side. So these occur between the molecules. That's why it's intermolecular. If it's within, covalent bonds are within the molecule. These are intramolecular. Okay, intramolecular within, intermolecular between the molecules. Okay, like between this one and another one. This is supposed to be an alkane. Okay, let me try and go with that one again, where it's better. Excuse for incredibly thick pen. So the strong covalent intramolecular forces are unaffected by heating and cooling. Okay. In covalent network solids, so that you can pause that. In covalent network of carbon and silicon, the covalent bonds need to be broken. but it's much harder. Okay, so the melting points and boiling points are much higher. The groups 1, 2 and 3, which are alkali metals, and these ones, okay, sorry, that's not true. For these groups, the metals, these 3 groups, these are very strong metallic bonds. Okay, so high melting points and boiling points. Okay, compared to covalent, that's compared to covalent elements, so nitrogen, oxygen, fluorine. These are very high melting boiling points. Okay, bye for now.